And you are of course most welcome. This is Project Euler problem number 11, largest product in a grid. In the 20 by 20 grid below, four numbers along a diagonal line have been marked in red. The product of these numbers is 1,788,696. What is the greatest product of four adjacent numbers in the same direction in the 20 by 20 grid? Okay, so there are four basic directions you can use in a grid like this. So there's across, there's down, there's diagonally down, and diagonally up. So how can we utilize those? Well, the brute force method is to take a grid like this, say this 0,8 down to this 23, get the products in every possible direction, so there's 4 across, 4 down and 2 diagonal, and then compare that to the global maximum. The problem with this method is you're going to be doing the same calculation multiple times. So in this grid we had the product 2 times 49 times 49 times 70, and if we move across to the next grid, you see we're making the same calculation again. So a better way to do this is to take a value, let's say this 8, and assess which directions we can go in. So from this 8 we can go down to the 52, we can go diagonally down to 23, we can go across to this 97, but we can't go diagonally up because there are no more rows. I get rows and columns mixed up because I'm an idiot. So this 63, on the other hand, we can go in all four directions. So we can go diagonally up to this 28, we can go across to the 91, we can go diagonally down to the 14, and we can go down to this 4. This of course will have a product of 0 because there is a 0 there. I haven't thought of a way to mitigate those. There is a way you could just you could say if this product contains a 0, skip it, but I don't think that would save any real time. So not an awful lot to say about this. We're going to code this anyway. Biggest equals 0 for I in range. So I is going to take care of the it'll tell us which row we're on. So in fact I might just call it R, just so it's easier to remember. So R in range 0 and 20, because of course it's 0 indexed. This is a two-dimensional array, it's going to be 0 indexed, and the last value is going to be 19. But of course Python is weird, so we have to put in 20. For column in range 0, 20. Okay, so we're going to start at a value, we're going to assess which directions we can go in, get the products of those directions, and then compare them to the global maximum. Okay, so what I should do then is call this global max. Right, so let's get the four directions and we'll set them to 0 to start with. There we go. Right, if j, okay, so we'll start with going across. So remember, oh, we don't have j, do we? We have c. So looking at the columns, if we're on the 16th column we can go across to make a product of four numbers, but if we're on the 17th column we can't go across anymore. So if c is less than 17, then we can go across. So across equals grid, so it's going to be row column, and we want to take the values from the next. We want to stay on the same row but take the values from the next 3 columns. So grc times gr. This portion is going to be especially tedious, I'm afraid. It's going to be lots of g's and r's and c's. So we're just working with two-dimensional arrays today. There's no real magic behind this algorithm at all. So c plus 2 and c plus 3. So then we've got a product going across. Now what about down? For down, obviously from the 16th row we can go down, but not the 17th. So it's going to be exactly the same with a few slight changes. If r is less than 17, then down equals g r c times g r c. So this time it's the r that's being incremented, so plus 1. In fact, we'll copy that. Go to plus 2 and then plus 3, and that's that. So now, slightly trickier, we want to go diagonally up. So to go diagonally up, we would have to be on at least the 3rd row, 0, 1, 2, 3. Because we're going up in this direction, we would have to be on no higher than the 16th column. So if c is less than 17 and r is greater than 2, if c is less than 17 and r is greater than 2, then we can go diagonally up. So diag up is g r c times, I think we're adding 1 to both of this time, so g r plus 1 c plus 1. I haven't quite typed that correctly. There we go. R plus 2 c plus 2 and r plus 3 c plus 3. There we go. And diagonally down. So for diagonally down we have to be in no lower than the 16th row and no further across than the 16th column. If c is less than 17 and r is less than 17, diag down is g r c times, now this is interesting, so say we start from here, it's going to go 0, 0 to 1, 1. Oh my goodness, this is wrong then, so that's going, one of these has got to be minus, hasn't it? So we're going up, then row has to go down. Oh my goodness, I'm such a dunce. Okay, r minus 1 minus 2. I would normally stop the video and just do it again, but I'm just going to keep going. R minus 3 c plus 3, and then I think diagonally down it is plus 1 plus 1. So plus 1 plus 1 plus 2 plus 2 plus 3. Right, there we go. That should have got it all correct. So then we find the local maximum. So local max is equal to the maximum of the four directions: across, down, diag up, diag down. And then if local max is bigger than global max, global max equals local max. Then we print off, oh, it doesn't like something. What have we done? Invalid syntax. What have we done? Oh, yep, two multiples. There we go. And then, right, then we print off. Yeah, I would normally just stop the video and start again, but it's getting late and I really can't be arsed. Global max. Print it off. And that's the correct answer. So that's problem number 11, and we are done with that. Thank you very much, and we'll see you next time for problem 12.